In this part, I will start talking about foundations. This foundation parts. We finished from the slab. I will start by foundation or footing, or how I will support the building in the soil. What type of foundation we use or we will learn in this course? I will talk about most popular type of foundation, isolating footing, and then I will talk how we import reaction from ETABS for the column reaction and wall reaction. Then I will talk about strip footing for the wall, then combined footing, two foundation together, two column together, bind together. Then I will talk about raft foundation, big one foundation for all the building. Then I will talk about uplift, if I have some uplift, some tension in the foundation, how I will model that uplift and how I will remove that uplift from my foundation by nonlinear analysis. Then after that I will talk about pile foundation, deep foundation, and I will more and more whatever we need in this course for foundation. I will talk about it: design, reinforcement, type, how I will choose the best type for my building, how I will read the soil report, what the parameter affecting in that design. I will start now in most easiest and most popular foundation, isolated footing design and modeling. What's isolating footing? Isolating footing, if you have one column or more column in the building, but I have one column, then I will make one foundation for that column. As we seen here, I have column with load, horizontal, vertical, moment, whatever, and then I will make footing for that column. It's pad footing or isolated footing. Sometimes we make it stepped footing like this. Why? To save concrete, because I need thickness here more because of bunching of the column and foundation, also because the moment here is bigger. For that I will use this. Sometimes there's a sloped foundation, it's coming like this. Why here also more thickness than here? Because if we seen, this is the load coming from columns, this is the foundation. The soil reaction, it will be like this, distributed. For that, it's like cantilever now. If you seen here, it's like cantilever. For that, we will, here the moment will be bigger. I will talk about that after. This is the real photo of the foundation, isolated footing. As you seen, column with foundation. Also, this is stepped foundation. This is sloped foundation. Why? What's most popular here? This one. Why? Okay, this is more economic, more saving, but in the work, in the construction, it's very difficult. I should cast this part first, then waiting, then cast this part again. Then if there's more 2 or 3 steps, I will wait, then cast again. Also in work, it's difficult to work this. If you need another layer of reinforcement, it will be sloped reinforcement. It's difficult to fix. For that, this is most popular. Sometimes you've seen the foundation, the column in the center of the foundation, as we seen here and here. This is in the center. Sometimes for some reason I cannot make the column in the center. It will be like this or like this in the one edge, or sometimes in the edge exactly here. Why? Sometimes because, for example, my plot, the owner plot, the plot of the building, I end here. This is our neighbor plot, not ours plot. For that I cannot go like this. Sometimes you've seen that from one side only the column in the edge exactly, it's coming from one side, the footing. Again, I will back here. This is reinforcement, how we reinforce the foundation. If the foundation is isolated footing for one column, mostly it's need one mesh of steel from two direction, in two direction, X and Y, but one mesh. There's no top foundation, there's no top reinforcement here, as we seen. Why? Because I rotate this. Actually, it's coming like this. Seen here? Actually, this is the column loading coming in the foundation. But I rotate it here to understand. I have this load coming from column, and this is the soil reaction. It's like now cantilever. I have this support and I have this load. For that, you seen this is tension. Here maximum tension. Here is 0. Here is compression. No need for reinforcement. You see? This is one mesh, as we've seen in actually. This is one mesh of reinforcement, bottom reinforcement in both direction, X and Y. Also, what this black? This we to protect the foundation, because the foundation coming in the soil, inside the soil. For that, you will expect there is some chemical in the soil. It will affect with time in the foundation, with the not in the concrete and in the steel also. For that, we protect the foundation in the some bitumen material or some layer of bitumen. Sometimes it's bitumen paint or bitumen layer membrane. It's coming. Now, if we want to design foundation, what we need before? What the first information I should get to design? For sure, I need the load from the columns, from in the columns. And I need the soil bearing capacity. I need how much the soil is stiff. From where I get this information? From soil report. I have here some soil report. It's real soil report for some project here in UAE, in Dubai. Let's see this. He give you too many information in this soil report. You get, it's as we seen, it's 64 pages, and this for one building, not building, it's for one like a villa, small building. For that 2 or 3 floor. If it's more bigger building, maybe you will get 200 page of soil report. What information I can get from here? As seen, he said this for ground and mezzanine only, 2 floor. He said this information he get it from me before, then he added here. He get this in value. In value, he said, for example, from 0 to 4, very loose. That means the soil is very loose. If in value from 0 to 4, from 4 to 10, it's loose. From 10 to 30, it's medium dense. It's dense. It's very dense. Over 50 in value, 50 time. Also, he give you here uncoefficient compressive strength of soil. Also, he give table. This is the table. If it's from megapascal, it's meganewton each meter square meter. If it's from this to this, it's medium. It's this limit. What's the limit? Then he said, this is our project. He said from 0 to half meter, we have silty fine sand. It's very fine sand. Then he said from 5 meter, he make borehole. Then he said from 5 meter, half meter to 1.8 or 2.3 meter different from area to area, because we take more one borehole. It's take 1, 2, 3, 4, for example, in the same plot. He said it's medium dense sand, for example. Then he said from 2.3 up to 12 meter, it's sandstone. It's type of stone, but it's sandstone. This is, we have 3 borehole, 1, 2, 3. The depth is 12 meter only, because this is 2-floor building. We don't have to do more than 12 meter. It's enough. Then he said, where's the water? Groundwater. It's 4.6, 4.5, 4.4. After 4.5, we get water. Groundwater. Then he explained here how we will calculate the reaction, the bearing capacity. Then he gave us this table. This is very important table. He said, if we have isolated footing or shallow foundation, the limit of settlement, deflection, settlement of soil, of foundation, or we see like how much the foundation will go deeper after we put the load, settlement, it's 25 millimeter. This is the maximum allowable. We shouldn't go more than 25 millimeter. What's the depth of foundation? He said, if you make your foundation in -1, the depth 1 meter, that means -1 from the 0, from our ground, or if you make it from 1.5, there's different result. How much maximum foundation width? He said 4 meter. We have for any foundation width, this is width, and this is length. He said the width shouldn't be more than 4. The maximum you can go is 4. Then he said gross allowable bearing pressure, it's 225 kilonewton each square meter. If we go 1 meter deep, if we go 1.5 meter, that means deeper. I found better soil from 1 meter. I reached to the Dennis soil. For that, he give you more 250 kilonewton each square meter. Then he said model of subgrade reaction. This is K. It's 27,000 kilonewton each cube meter. In SAFE, in modeling, in any software modeling, you cannot enter this number. You should enter this number. For that, this is very important. Then he said, if you make raft foundation, it's big foundation, you can use 50 millimeter settlement, and the depth will be 2 to 3 meters. This is for water tank. If we have water tank, it will be deeper than normal foundation. The maximum width is 10 meters. Then he said the bearing capacity, net allowable bearing capacity, it's 300, and module of subgrade, it's 18,000. Imagine here there's something strange. I will talk about it. Here 250, we get 30,000. Here why is it 300? It's near this. We get, should be more than 30, because here is less than this. For that, this is less. This more, we get more. This is more, we get less. More, less. Why? What's reason? What's this? How we can calculate this? I will tell you how. Let's back again. Here I make table, small table to calculate K. What's K? This is K. K. You see? Module subgrade reaction. This is K. How much, if we have here soil, how much module subgrade reaction? How much reaction for this? First, how much factor of safety in the soil? Usually it's 3. Let's see the calculation, maybe we can get it, but mostly it's between 2.5 up to 3, not more, not less. You see, this is the plot. This is the, he will put the location of the boreholes where he make the boreholes. Let's back again to here. This is the location, 1, 2, 3. He make 3 borehole in the same plot. You see in here, he used this equation to calculate. Then he not mentioned, but anyway, it's a 3 double. That mean he get, that mean, what's mean 3? 3 here, when he calculate the allowable pressure, for example, for this, he said he get 750 kilonewton each square meter. Then he divided in 3, then he said it's 250. Again, back here. How much factor of safety? It's a 3. How much bearing capacity of soil? It's 300. This one, let's calculate this. I will calculate this example. I will take this example. This. How much bearing capacity? It's a 300, as we seen. It's a 300. How much allowable settlement? It's 50. It's 50. This 50 millimeter. Allowable settlement in meter. Sorry, in meter. It's 0.05 meter. Now I only divide in 1000. This 1000. How much bearing capacity? Ultimate. This is because this is service. He divide in 3. It's 900. This multiply factor of safety. It's 900. He said there's equation B equal B, the reaction pressure. This reaction, this is B, bearing capacity, equal to K multiply delta. What's K? That what we want. Spring constant. This spring constant or module subgrade reaction. Delta is the settlement. How much settlement? Let's say that mean it's 900 divided in 0.05 in meter, all in meter. This is meter, this is meter. It's 18,000 here. If we back to soil robot, here you see it's 18,000. This is right. Let's calculate this. We see the result. I have settlement. You see this 25 millimeter. For that, I have here 250. This one 250 multiply factor of 33. This is now ultimate 750 kilonewton each square meter, divided in settlement by meter 0.025. This one by meter, it's 30,000. You see, it's 30,000. If you want, I will calculate third one. 225 multiply 3 factor of 50 divided in 0.025 millimeter, it's 27,000. This is the module subgrade reaction K, how we calculate it or how they will calculate it, because usually we get it ready from soil report. In next lesson, I will start take example in this foundation. I will model this example in SAFE. Then I will see the result and I will design this foundation. Thank you.